Hello, math students. Today we're going to be going over a math lesson dealing with special lines. So if you were able to do the other lessons up to this point about linear equations and how to write linear equations and how to transform them and things like that, then this lesson should be relatively easy. We're basically going to be going over a lot, reviewing a lot of how to find the slope of a line, and how to write the equation of a line given a particular slope. A couple things we're going to talk about also is parallel and perpendicular lines. And I'll give you a little bit of a spoiler up ahead, is that parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. I've talked about this in other lessons, but we're going to go over it in full detail here. So if it doesn't fully make sense right now, that's okay. Just follow along, write down everything I write, and I guarantee it'll make a lot more sense. All right. Well, with that, let's go ahead and get started with the tutorial. Here, the warm-up on page 5. Let's go ahead and get started. It says, consider lines AB and CD. So we have lines AB there in blue and CD there in green. And we want to find the slope of line AB and the slope of line CD. Well, remember, to find the slope of a line, it's the rise over run. Hopefully you remember that. So I'm going to put, usually we use the letter M. I'm going to put M and then I'll put a little AB here to show you that this is the slope for line AB. And we would do the rise over run. So I usually go at the leftmost point and then move right. So going from the leftmost point on line AB, which is point A, we would rise 1, 2, 3, 4, run 2. So rise 4, run 2. And we can simplify this fraction. 4 divided by 2 is 2. So the slope of line AB is 2. Let's find the slope of line CD. I'll use a different color here. So for CD, so the slope of line CD is going to be, well, let's go from point C to point D here. So the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Rise 12, run 1, 2, 3, 4, 5, 6. Rise 12, run 6. Divide that out. 12 divided by 6 is 2. Notice these two lines have the same slope. These two lines both have a slope of 2. So would these lines be parallel? Well, yes, they would. And we can see they certainly look parallel, right? Parallel lines mean that no matter how far you extend those lines, they will never touch each other. Okay, so these are indeed parallel lines, and I know that because they have the same slope. All right, let's go ahead and move on. You can go ahead and move ahead until it stops you. But parallel lines are an important topic because they're a big part of many geometric figures, such as parallelograms, rectangles, trapezoids, and many other rectangular objects you're going to see all over the world, right? Even this computer screen that you're probably looking at is a rectangle, which has parallel lines. So let's talk a little bit more about parallel lines. So which equation represents a line that is parallel to line JK and passes through the point P, 6, -2. So first, let's go ahead and find the slope of line JK. So remember, parallel lines have the same slope. So if I'm finding a line that has the same slope as line JK, first thing I need to do is find the slope of this line. So the slope is the rise, 1, 2, 3. So rise 3. So our slope in this case, rise 3, run 1, 2, 3, 4, 5, 6. Okay, and I can simplify this fraction. 6 over 3 reduces down to 1/2. Okay, so our slope is half. And you could simplify a fraction by dividing both by 3 in this case. Okay, giving us 1/2 as our slope. Great. So any parallel line must also have that same slope. So all parallel lines will have a slope of 1/2. Well, let's take a look at our answer choices. You can see the first two answer choices. These are basically our only two options because these are the two that would be parallel to our line JK, because both these two equations have the same slope, a slope of 1/2. All right, but it has that other criteria. It says that it also has to pass through the point 6 comma -2. So we need to figure out which of these equations passes through this point 6 comma -2. Well, how do we do that? Well, I'm just going to go ahead and grab these two equations. These are our two possible answer choices. I'm not sure which one's correct yet, but we need it to pass through 6 comma -2. All right. So what that means is this is your x coordinate and this is your y coordinate. So if I replace x with 6 and replace y with -2, the correct answer should give me a true statement. You'll see what I mean. So here I'm going to go ahead and try this first equation. So I'm going to replace the x with 6, and I'm going to replace the y with -2. So how does that look? Well, I'm going to go ahead and change to blue here. So I'm going to replace y with -2, okay? And then it'll be 1/2. See how it says 1/2 x? That means 1/2 times x. Well, I'm going to replace that x with the x coordinate. So that's 6. And then it has a -14. So we're going to see, is this a true statement? Well, what's half of 6? Well, remember, I've talked about how to multiply a whole number times a fraction many times, but basically you take the whole number, multiply by the top, then divide by the bottom. So 6 times 1 is 6. 6 divided by 2 is 3. So this becomes -2 equals, and this becomes 3 minus 14, which then ends -2. 3 minus 14 is -11. Are these actually equal? Well, no, these are not equal. These are not equal all the way down. By the way, my 2 kind of looks like a Z, but just know that I always, if I mean Z, I put a little cross through it. So you see that this means 2. Okay. All right. Well, these are not equal, so this one is wrong. So that means this one must be correct, but let's just double check. So I'm going to replace my x and y with the coordinates here, replacing x with 6 and y with -2. So -2, 1/2. I'm replacing the x with 6, so 1/2 x becomes 1/2 times 6. This is -2 equals, what's half of 6? 3. 3 minus 5. And yeah, 3 minus 5, that is -2. So that is correct. So this is the equation of a line that passes through this point, 6 comma -2, and it's also parallel to this line here because they have the same slope. So we know that this is the correct answer here. All right, once you're done with that, let's go ahead and move along. Line FG is represented by the equation 8x plus 3y equals 10. Which value is the slope of a line perpendicular to line FG? Well, perpendicular is different than parallel, okay? That's one thing you need, that's a distinction that you need to have concretely in your mind. Parallel is when the two lines don't touch. So in the example we had before, like if we have y equals 1/2 x, 1/2 x minus 5, that was one of the equations we had before. You can see the line here. And I could draw a parallel line here, y equals, and by the way, I'm using the graphing calculator Desmos. And notice that these two lines, the green and the blue here, are parallel. Now, I knew that they were going to be parallel because I made sure that they had the same slope. In this case, I gave them both a slope of 1/2. And you could see that here. By the way, you should have Desmos open and just use it as a tool for graphing any lines that you're not sure about. You could always use Desmos to graph those lines and get a good idea. And we can see here that these are parallel, right? And I can add a third equation. As long as I create an equation that has the same slope, then these lines will definitely be parallel, okay? So here my third equation, I put plus 6, and you can see the three lines, they're all parallel to one another, okay? They're all parallel. Now, but what does perpendicular mean? So I'm going to go ahead and erase these two. Perpendicular lines, they cross at a 90-degree angle. So what's important about perpendicular lines is that they cross at a 90-degree angle, a right angle, okay? So what would be the equation of a line that is perpendicular to this blue line? Well, I'll show you. Y equals, and here I'd do -2x, and it doesn't matter the y-intercept, +1, for example. Okay. Now notice these two lines, this blue and black lines here, they cross at a 90-degree angle. You can see that there, cross at a 90-degree angle. Now, what do we notice about their slopes? Well, for one thing, they are opposite signs, right? Notice the blue line has a slope of +1/2, whereas the black line has a slope of -2. So they're different signs, one positive, one negative. All right. Now, the other important thing is that they are reciprocals to one another. Now, what does that mean? So notice the blue line, its slope is 1/2, but the black line, it's perpendicular, has a slope of -2/1. So not only are they different signs, one positive, one negative, but they're flipped. Notice the fraction is flipped, 1/2 versus 2/1. Perpendicular lines have slopes that are opposite sign and also reciprocal, meaning the fraction is flipped. So let's say I change this, this blue line. I'm going to change it to 5/2 for its slope. Well, now they're no longer perpendicular. What do you think I would have to change this one's slope to in order to create perpendicular lines? Well, instead of 5/2, let's flip it 2/5. And we can see here, yes, indeed, these lines are now perpendicular, crossing at a 90-degree angle, okay? And again, you can see the slopes are different signs, one positive, one negative, and they're reciprocals, 5/2, and then the other one, 2/5. So that's what perpendicular means, that they are opposite signs. The slopes are opposite signs, but also reciprocal, opposite reciprocals, okay? So let's go ahead and try to answer this question here. It says, line FG is represented by the equation AX plus 3Y equals 10. Which of these has which of the slopes would be of a line that's perpendicular to line FG? Well, the first thing I would need to do is I need to find the slope of our line. So let's go ahead and find the slope of our line. Now, the way we can do this is get our equation in y equals mx plus b form, right? Slope intercept form. Once we're in this form, getting y by itself, then whatever the value of m is, that'll tell us the slope of our line, the slope of FG. Once we know the slope of FG, then we can find the slope of any perpendicular line. All right, so let's go ahead and solve for y. We want to get y by itself in this equation. So I'm going to go ahead and write the equation. And by the way, whatever I write, you should be writing. This will give you the fullest understanding. You learn by doing, not by just watching. Okay, so pencil, paper, calculator right in front of you, doing everything I do. Believe me, that'll make 10 times the difference. Okay, now I want to solve for y. I want to get y by itself, just like it is in this equation. See how y is by itself? So how do I get y by itself in this case? First thing I'm going to do is subtract 8x. I'm going to subtract 8x on both sides of the equation. Remember, whatever I do on one side of the equation, you have to do on the other side of the equation in order to keep it equal. So I've got -8x plus 10. I can't combine these because the -8x can't combine with the 10. They're not like terms, right? The 10 is a constant. Then to help me get y by itself, I'm going to go ahead and divide by 3. This will get me y by itself. But I have to divide these, the other side of the equation, also by 3. Remember, whatever we do on one side of the equation, you have to do the exact same thing on the other side. So we got -8/3 x plus 10/3. Okay, I know it's all in fractions, but that's okay. So we know the slope of our line. The slope of FG is whatever value m is, which in our case m is whatever's next to the x. So our m is -8/3. So this is the slope of our line, any perpendicular line would have to have a slope of opposite sign. So since this is negative, the opposite sign would be positive. And then we flip the fraction. So instead of 8/3, it's 3/8, positive 3/8. So any line with a slope of positive 3/8 will be perpendicular to our line. Okay. And I can kind of show that. I could show that on Desmos too. Let's see, it's 8x plus 3y equals 10. 8x plus 3y equals 10. All right, so here's the line. This is the line FG. And I can have any perpendicular line would have to have a slope of, what was it? 3/8. Okay, so 3/8 x, and I could put anything here, maybe -6. Okay. And you can see, yes, these two lines are crossing at a right angle. Yeah, a 90-degree angle. So yes, these two lines are perpendicular to each other. We can see that there. Okay, so let's go ahead and move on. All right, page 17 is the activity. In a local park, there is a straight path passing by a fountain and a gazebo. The path is represented by a line passing through the points F, which is at 4:14, and G, which is at 7:2 on the map as shown. All right, so we can see our 2 points here. We have point F, which is at 4:14. So 4:14, you can see point F there. And point G is at 7:2. So we can see point G at 7:2, where the gazebo is. Okay, great. The first new path will increase access to the fountain. It will be perpendicular to the existing path and pass through point F, 4:14. So we want to write an equation that is perpendicular to FG, and it passes through the point F. So it passes through 4:14. So the first thing I need to do is I need to find the equation, or at least the slope of FG. So how do we find the slope of FG in this case? Well, remember, the slope is the rise over run. And I always start with the leftmost point. I think that makes it a bit simpler. Start with the leftmost point, move right. Now in this case, would my rise be positive? Am I going up? To go from F to G, would I need to go up or need to go down? Well, to go from F to G, I would need to go down. So my slope is actually going to be negative in this case. We talked about this a few lessons ago, but negative slopes go down as you go from left to right. And yes, this FG would have a negative slope in this case. So because you're going down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went down 12. So I'm going to put -12 here for our rise. And then the run is over 1, 2, 3. And to the right, 3. Okay. This fraction you could simplify to -4/1, or if you like, just -4. Okay, so this is the slope of line FG. Now, what would be the slope of any perpendicular line? Well, a perpendicular line would have to have a slope that is the opposite sign and reciprocal. So instead of 4/1, you'd flip that, 1/4. So the slope of any perpendicular line would have to be positive 1/4. Okay, so since we're trying to create a perpendicular line, we know our slope is going to be positive 1/4. So for my M here, I'm going to put positive 1/4. That's the slope of any perpendicular line. Now we still need to find the y-intercept. Now, how do we do that? Well, remember, our point, or our line, I should say, needs to go through the point F, point 4:14. So I could use our equation to help us find B. I know it needs to pass through 4:14. So I'm going to replace the X with 4 and the Y with 14. This will help me find the y-intercept, help me find B. So I'm going to replace the Y with 14, because that's the point. And then I'm replacing the x with 4 because that's from the coordinate point as well. How do I multiply 1/4 times 4? Remember, when we multiply a whole number times a fraction, you multiply times the top, then divide by the bottom. So 4 times 1 is 4. 4 divided by 4 is 1. So this gives us 14 equals 1 plus b. Now to solve for b, or in other words, get b by itself, we're going to go ahead and subtract 1 on both sides of this equation, giving us that 13 is the value of b. Perfect. And that's it. Let's go ahead and go on to part B here. The second new path will increase the access to the gazebo. It will be perpendicular to the existing path and pass through 7, 2, point G. So which equation is that? Well, remember, just like the previous question, it needs to be perpendicular to FG, which means it has to have the slope of 1/4, same as the slope is from this question, right? Well, only one of those has a slope of 1/4, so we're done. This is the only one that will be perpendicular to FG. All these others do not have a slope that's the opposite reciprocal. So none of these other lines would be perpendicular to FG. Now, what I could do, I want to show you something here. So we're going to go ahead and graph these two lines on Desmos. So y equals 1/4 x plus 13. All right. And so that's up here. Okay, that's the red line. And then the other equation was 1/4 x plus 1/4. What do we notice about these two lines? Well, we know that they're both perpendicular to FG from the problem, but notice these two lines, well, aren't these parallel to each other? So these are parallel to each other, and you can tell because they have the same slope. You can see they both have a slope of 1/4 in this case, which tells us, yeah, these are parallel to each other. So if two lines are perpendicular to the same line, then they have to have the same slope, which basically tells us that those are parallel to each other. So any two lines that are perpendicular to the same line must be parallel to each other because they have to have the same slope. So the two new paths will be parallel to each other because their slopes are the same. Let's go ahead and move on. Now we're going to talk about lines that are purely vertical and then lines that are purely horizontal, okay? The equation of a vertical line passing through -1, 2. Let me see if I can show you what a vertical line looks like versus a horizontal line. So in this case, we wanted a vertical line that passes through -1, 2. So it needs to pass through the point -1, 2. I'm going to go ahead and place that point there. And we want a vertical line that passes through that. Vertical means up and down. So we're looking for a line that goes straight up and down. A horizontal line is left to right. So for example, the y-axis is a vertical line. The x-axis is a horizontal line. One way to help you remember is that horizontal is like the horizon, right? When you look at the horizon, it's like this, right? That's horizontal. Vertical, up and down. All right, so how do I create a line that's a vertical line that passes through this point? Well, any vertical line will be in the form x equals something and just a constant, okay? So x equals 6. Oh, look at that. My blue line here is just a vertical line that passes through the x coordinate of 6. So notice x equals 6 is a vertical line. See that? And x equals whatever you want is how you create vertical lines at various locations. So x equals 1. You can see it's a vertical line going through x equals 1. X equals -4 is a vertical line going through -4 there. All right. So, and I can move that along according to this slider here. Okay. X equals 0 is the same as the y-axis. That's interesting. So if I want a vertical line that goes through this point being -1, 2, we're going to just do x equals -1. Notice it's a vertical line and it passes through the point that we want. You see that? So any vertical line is going to be x equals something. And if I want to go through a particular point, I just put it as x equals and then the x coordinate. What about a horizontal line? A horizontal line goes like this. Well, instead of x equals, those are in the form y equals. So for example, y equals -1, you can see it forms this line, horizontal line, that passes through -1 on the y-axis. See that? Y equals whatever number you want creates a horizontal line at that location. So y equals 5, horizontal line through the y value of 5. All right. Now, if I wanted to go through the point -1, 2, here I'll just put y equals 2. So notice now we have a horizontal line that's going through -1, 2. So y equals 2 is what we're looking for here. All right. On page 22, So with this problem, what we want to create is a line that's perpendicular to the y-axis. Now, if you remember, the y-axis is vertical. So if I want a line that's perpendicular to that, I'm going to want a line that's horizontal. Well, just like we did in the previous section, how do we create a line that's horizontal? Well, it'll be y equals something. So it's going to be one of these ones that say y equals. Now, I know it's going to be y equals, in this case, 7. And I know that because the y coordinate is 7. And we could see that here. Let's go ahead and go to Desmos. And I want to pass through the line -4, 7. And I need it to be perpendicular to the y-axis. So here I've got my point, -4, 7. And it'll be y equals, in this case, 7. Notice that the y-axis and this horizontal line are perpendicular. In other words, they cross at a 90-degree angle. And it goes to the point -4, 7. So that's your line there. And again, I didn't need to graph it because I already knew, since it's perpendicular to the y-axis, I know it'll be horizontal. So that tells me it's going to be y equals. And I know it's y equals, in this case, 7, because that's our y coordinate. Well, that's it for the tutorial. Let's go ahead and look on page 24. And it gives you a couple of additional notes. Perhaps write these down if you're not sure about them. Remember, parallel lines, they do not touch each other. And the equations of parallel lines have the same slope. Perpendicular lines, they do cross each other. Specifically, they cross each other at a 90-degree angle, a right angle. And the slopes of perpendicular lines are opposite reciprocals. So for example, 1/3 and -3, if those are the slopes of the two lines, they would be perpendicular. Horizontal lines have a slope of 0, and they're always in the form y equals, and then whatever the y coordinate is. Vertical lines have an undefined slope, and they are always in the equation form x equals and a constant, wherever the x coordinate is. Well, with that, let's go ahead and move on to the practice. Here, let's go ahead and take a look. And you only have 5 questions on the practice, but I'm going to be going over 10 questions. Please follow along with me and write down everything I write, even the questions that you don't necessarily have. That'll help you gain a fuller understanding. Which equation represents a vertical line passing through 5, -4? Well, if it's a vertical line, I know it's in the form x equals, so it's either this one or this one. Should it be x equals 5 or x equals -4? Well, remember, this is the x coordinate, this is the y coordinate. So if I'm in the form x equals, it should be x equals whatever the x coordinate is. In this case, x equals 5. Which equation represents a line that is perpendicular to y equals 1/6 and passes through the point -8, 2. So since it's in the form, this line is in the form y equals, well, therefore I know that it's going to be a horizontal line at y value of 1/6. So this y equals 1/6 will be like right here, let's say. Now I want a line that's perpendicular, so I want a vertical line. I want a vertical line that passes through -8, -2. So let's say -8, -2 is maybe down here. And I want a vertical line that passes through that. So what would that look like? Well, it would look like this. Since it's a vertical line, it'll be of the form x equals, and again, x equals the x coordinate. If it's in the form y equals, you'd use the y coordinate. Which equation represents a line that is parallel to y equals 4? So again, y equals 4 would be a horizontal line at 4. So this is, let's say at 4, this is y equals 4. Well, if I want a line that's parallel to that, it would also have to be horizontal as well. So it would have to be y, so any parallel line would have to be of the form y equals whatever as well. So y equals something. And it doesn't really matter what it is, but except it has to pass through -3, 1. So actually, -3, 1 is perhaps down here. So it'll be of the form y equals. Should this be y equals -3 or y equals 1? Well, since it's in the form y equals, you want to use the y coordinate. These two lines are parallel. Okay. Which equation represents a line that is perpendicular to line FG? So we want perpendicular lines, which means their slopes are going to be opposite reciprocals. So opposite signs and also flipped. Let's go ahead and find the slope of the line we have here, line FG. I like to start left to right, so I'm going to start with point G, and I'm going to run to find the slope. The rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So rise 12. And run 1, 2, 3, 4. So I have a slope of 3. So the slope of line FG is 3. So a perpendicular line would have to be the opposite sign, so negative. Perpendicular line would have a negative slope, and reciprocal. So instead of 3/1, it would be 1/3. So any line with a slope of -1/3 would be perpendicular to this line. This one right here has a slope of -1/3. The other ones do not. Which equation represents a line that is parallel? So parallel lines have the same slope. So I need a line that has the same slope, 3/4. Okay, so it's either this one or it's this one. These both would be parallel to this line. But I need it to pass through this point, -12, 36. Recall that this is your x coordinate, this is your y coordinate. So I would need to replace x and y with these coordinates here to find the correct equation. Now the correct equation should produce a true statement, like 5 equals 5, not a false statement like 5 equals 20 or something. Okay, so let's see. It's one of these two answer choices. I want to see which one would produce a true statement with this coordinate point. So I'm going to replace x with -12, y with 36. I'm going to try this first equation here. So 36, I'm replacing y with 36. 3/4 times x is -12, and then minus 39. I'm hoping that this gives me 36 here. So how do we multiply a fraction times a whole number? Well, remember, you multiply the whole number times the top of the fraction, so times the numerator, then divide by the bottom. So negative 12 times 3 in this case, that gives me negative 36. Divided by 4 gives me negative 9. So this becomes negative 9 minus 39. So this becomes negative 9 here. Negative 9 minus 39, which is negative 48. So is this equal to the 36 here? Well, no, it's not equal. So that means this is not the correct answer. Even though this line would be parallel to this, it does not pass through this point. So that means it has to be this last answer choice. But let's just double check. I've replaced the x and y, the y with 36. Maybe I'll use a different color. 36 equals, and here we're replacing the x with negative 12 once again. Oh, that should say plus 45. Whoops, I was copying the previous problem or previous answer choice. Should be plus 45 from this. Okay, negative 12 times 3/4. Well, we already talked about previously, but you multiply times the top, divide by the bottom. That should give you negative 9 plus 45. And this does indeed give you 36, doesn't it? So that's why we know that that matches, so that's good. Which equation represents a horizontal line? So horizontal lines are always in the form y equals, and it passes through the point 9 comma negative 7. Should this be y equals 9 or y equals negative 7? Well, in this case, y equals negative 7 because that's a y coordinate there. Vertical lines are in the form x equals. Horizontal lines are in the form y equals. Which equation represents a line that is perpendicular to this line and passes through negative 10 comma 20? Well, since it's perpendicular to this line, I would look at the slope. The slope is 2/5. So a perpendicular line would have to have a slope of negative 5/2. So first of all, the correct answer would have to have a slope of negative 5/2. So it's either this first one or it's this second one. It's one of these two answer choices here. Now I'm going to replace x and y with these coordinate points here to figure out which one's correct. I replace the x with negative 10, the y with 20. So let's go ahead and try this first equation. I'm going to replace the y with 20. So instead of y equals, it's 20 equals. Then negative 5/2 times x. I'm going to replace the x with negative 10. And then minus 5. Okay, hopefully this is equal, and then that'll give us the correct answer. So negative 5/2 times negative 10. Well, negative times a negative is positive. But remember, we multiply times the top, divide by the bottom. Whenever you're multiplying a whole number times a fraction, multiply times the numerator, divide by the denominator. So negative 10 times negative 5 is 50. 50 divided by 2 is 25. So this becomes 25, and we still have that minus 5 there, giving us 20. Oh yeah, that is correct. See how it matches here? That's great. So not only is it perpendicular to this line, because it has the opposite reciprocal slope, but it also goes to this point we checked, okay, because it produces 20 there, or same amount. If you tried this one, it would produce not an equal statement. Okay. Consider the linear equation shown here. Y equals negative 4 equals 3x minus 2. The slope is, well, this equation is actually in point slope form. Point slope form. And that means that whatever this number is right here, that tells you the slope. Because point slope form looks like this. Y minus a y coordinate equals the slope and then x minus an x coordinate. We talked about this quite a few lessons ago. It's okay if you don't fully remember. This is different than the slope-intercept form that we use most often. The y equals mx plus b, that's the slope-intercept form. That's what we use mostly. But this is another form of what linear equations can come looking as, which is the point slope form. Okay, but whatever your m is, that's in front of this parentheses that has the x's. See that? So in this case, our m is 3. So our slope is 3. What about the point that it passes through? Well, the point comes from the x and y, x sub 1 and y sub 1. So in this case, our x sub 1 is 2, and our y sub 1 is 4. So it must pass through 2, 4. Which equation represents a line that is parallel to the y-axis? So when you think of the coordinate grid, this is your y-axis. The y-axis is vertical. So if I want a line that's parallel to that, we also need a vertical line. So what would be a vertical line? Well, a vertical line looks like this, and it's always in the form x equals something, right? So the only one that would produce a vertical line is this one right here. Drag the equations to the correct locations on the table. Not all equations will be used. Determine which equations are parallel to line BC, so meaning has the same slope as line BC, and which ones are perpendicular to line BC, meaning the slopes will be opposite reciprocals. Well, in this case, what would be, first we need to do is find the slope of line BC. So I start with point B, and I'm going to go to point C. And we want to find the slope, you do the rise over run. So the rise would be 1, 2, 3, 4, 5, 6. And our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 6/9. So that's the slope of line BC. We can reduce this fraction by a factor of 3 because both of these numbers are multiples of 3. So divide them both by 3 to get 2/3. So the slope of this line is 6/9, or in other words, 2/3. So any of these that have a slope of 2/3 will be parallel. So for parallel lines, we're looking for a slope of 2/3. For perpendicular lines, we're looking for a slope of -3/2. Notice it's the opposite sign and reciprocal, flipped. So let's figure out which of these would be considered parallel and which ones would be perpendicular. So let's go ahead and find the slope of each of these lines, starting here. Now, how do we find the slope? Well, what we can do is just solve for y. In other words, get y by itself. Once we have that, once you're in the form y equals mx plus b, then we can clearly and easily see what the slope of the line is. It's whatever the coefficient for x is. So let's go ahead and try this first one here. Getting y by itself, we're going to start by subtracting 3x on both sides of the equation. Remember, whatever you do on one side of the equation, you have to do on the other side of the equation. So we have -3x plus 1. Then divide both sides by -2. It really doesn't matter what your y-intercept ends up being, but here we have a negative over a negative. So negative over a negative makes positive. So positive 3/2 x. And then this is -1/2. Oh, that's supposed to be an x there. Okay. Is this line going to be parallel, perpendicular, or neither? Well, does it have a slope of 2/3? No. Does it have a slope of -3/2? No. So this one's a neither. So this one's not going to go in either box. Okay. Let's go ahead and try the next one. So my first step, again, I want to get y by itself so I can be in slope-intercept form, and then we'll be able to find the slope easily. So I'm going to start by subtracting 4x on both sides of the equation. This will give me 6y on the left equals -4x plus 3. Then, to help me get y by itself, we're going to divide both sides by 6. Remember, whatever you do on one side of the equation, you have to do on the other side of the equation to keep it equal. Now this fraction, 4 over 6, we can reduce that by a factor of 2, giving us negative 2/3 x. And this is 1. This reduces to 1/2 because 3 is half of 6. Now, does this look like parallel? Well, no. Is it perpendicular? Well, no. So this one's going to go in neither as well. Let's go ahead and try the next one. Again, we want to get y by itself. So I'm going to start by subtracting 3x on both sides of the equation. This cancels here on the left, leaving us with 2y equals negative 3x plus 5. Remember, I can't combine this negative 3x and 5. We can't combine those because the negative 3 has an x attached, but the 5 is a constant. So those don't just combine like that. They wouldn't be what we call like terms. They're not like terms. Okay, divide by 2 on both sides of the equation to get y by itself. So here we have y equals negative 3 over 2x plus 5 over 2. Okay, negative 3 over 2. Oh, that's what we're looking for. So this is a perpendicular line because it has a negative 3 over 2. So this one would go into this box here. Let's try the last one. Now, I could probably guess that it would go into parallel lines since we have nothing over there yet. But we're going to go ahead and subtract 4x in order to help us get y by itself. Subtract 4x on both sides of the equation. So negative 4x plus 7 here on the right. Divide both sides by negative 6, in order to get y by itself. This cancels this negative 6. So you have y equals, this negative over negative becomes positive. So, and 4 over 6, we can reduce this fraction by a factor of 2. So that gives us 2/3 x. Positive, because a negative over negative makes positive. And that's negative 7/6. Okay. Again, we're only looking at the slope to help us determine whether it's parallel or perpendicular. Well, in this case, 2/3 is what we're looking for. So this line would be parallel to BC. All right. Well, that covers all the questions in the practice. Now let's go ahead and go over the mastery test. And you're going to be offered 5 questions from this mastery test, but I'm going to go over a total of 20 questions. You'll be given a sample of these 20 questions. But if you follow along, do everything I do, it'll make complete sense. And by the way, make sure to like, comment, subscribe if you found this video useful. And if you really, really want to say thank you, you can share it with someone else who would also hopefully find it useful as well. Okay. Well, with that, let's go ahead and get started. This first question on the mastery test says, determine which equations are parallel to line JK and which is perpendicular to line JK. This is just like what we did in the last question from the practice question number 10. This is essentially the same question, just using a different line. So first, let's go over and find the slope of line JK. Now, looking at this line JK, can we tell whether or not it's going to be a positive slope or a negative slope? Well, this line is going downwards as we go from left to right. So that tells me this is line JK will have a negative slope. But let's just go ahead and calculate its slope. Again, finding the rise over run. So from J, I usually start left to right. So I'm going to start with point J. And my rise is actually going down, right? So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go down 10, so that's negative 10. And then how much do we run? 1, 2, 3, 4, 5, 6. Run 6. So the slope of this line would be negative 10 over 6. I could reduce this by a factor of 2, so negative 5/3. So any parallel line would have to have the same slope. So of these equations, we're looking for parallel lines. So any line that has a slope of -5/3 would be parallel. And a perpendicular line would have a slope of the opposite reciprocal. So you would take the opposite sign. So instead of -5/3, it's positive, and you flip it. So instead of 5/3, it's 3/5. And again, positive because it's opposite reciprocal to find perpendicular lines. So if the slope, so when you try to figure out the slopes of these equations, if the slope is -5/3, it's parallel. If the slope is positive 3/5, then it's perpendicular. And if it's neither of those slopes, then don't put it in either category. So I'll show you how to find the slope. We'll just go with this first one here. To find the slope, essentially what you want to do is get y by itself. So we want to solve for y. So that way we can get into the form y equals mx plus b, get into this form, and find the value of m, find the value of the slope. So how do we go ahead and do that? Well, we would start by subtracting 6x. So I'm trying to get y by itself here. So I'm going to subtract 6x to get me started. That leaves us with 10y here on the left equals -6x plus 11. I can't combine those terms. Then divide by 10 on both sides of the equation to help me get y by itself. That way we are in our slope-intercept form. So y equals, this can reduce to -3/5 x. So that tells me the slope of this line is -3/5 plus 11/10. Okay, so our slope is -3/5. Would that be a parallel line? Would that be a perpendicular line? Or neither? Okay, well, in this case, it's a neither, because it's not -5/3 and it's not 3/5. See, this slope does not match those slopes down there. So that tells me that this one is a neither. So you're not going to put it in either category. Find the slopes of these other equations and figure out which category they should go in. Okay, let's go here. Okay, great. Now the next question says, which of the equations below contains the 2 points listed, 5, 9, and also 6, 9. So if we look at where those coordinate points are, 5, 9 would be like 5, 9, somewhere around here. And then 6, 9 is right next to it. So if it contains these 2 points, that means our line would have to be a horizontal line. Horizontal line. And remember, horizontal lines are always in the form y equals. Okay, so figure out which of those is the correct way to write that. Y equals, what would be the equation that goes through both of these points? Which equation represents a line that is perpendicular to y equals 1/5 and passes through -4, -3? So the first thing, I'm going to graph my point, -4, -3. So -4, -3. This is like down here. Okay. Then I'm going to go ahead and draw the line y equals 1/5. So y equals 1/5 would be like here. It's a horizontal line. Remember, horizontal lines are always in the form y equals. Vertical lines are in the form x equals. So I'm looking for a line that's perpendicular to this line. So a perpendicular line would have to be vertical, wouldn't it? Okay, so it's a vertical line, so it'll be in the form x equals, and it has to go through this point. So figure out which of those it would be. Which equation represents a line that's parallel to y equals 2 and passes through -1, -6? So I'm going to go ahead and graph our point. It's -1, -6, so maybe down here somewhere. You don't have to be, I'm not being too precise here. Then y equals 2. Y equals 2 would look something like this. It's a horizontal line. Remember, horizontal lines are always in the form y equals. So this is our y equals 2. Now I want a line that's parallel to that. So if it's parallel to that, that means it would also be a horizontal line and it would pass through this point. So which of these equations would produce a horizontal line that also passes through this point? Which equation represents a line that's perpendicular to PQ? So the first thing I want to do is find the slope of line PQ in this case. How do we find the slope of line PQ? Well, we do the rise over run. I'm going to start at point P. I like to go left to right when I calculate my slope. I feel like it eliminates a little bit of the confusion. So I'm going to start with point P here and figure out the slope, the rise over run. So the rise in this case is actually downward, right? I'm going down. I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, down 12. So that's negative 12. And then over how much? 1, 2, 3, 4, over 4. Okay, great. That tells me the slope of line PQ is negative 3 over 1. I'm reducing by a factor of 4 here, right? Dividing both numerator and denominator by 4. Or if you like, just negative 3. So our slope of line PQ is negative 3. So which of these lines would be perpendicular to that? So in other words, I'm looking for a slope that is opposite reciprocal to negative 3 over 1. Which equation represents a vertical line passes through 7, negative 3. So remember, a vertical line is always in the form x equals. So figure out which equation would be a vertical line going through this point. Which equation represents a line that is perpendicular to y equals 3/4 x plus 1 and passes through negative 5, 11. Well, since it's a perpendicular to this one, that means I know my line, my perpendicular line, will have to have y equals opposite reciprocal slope. So negative 4/3. I know my perpendicular line will have a slope of negative 4/3 x and then plus the y-intercept. Okay, so I know it's either A or it's B because both of these lines would be perpendicular to our given line because both of them contain the correct slope, negative 4/3. Now, which one of these passes through the point? Negative 5, 11. So what you would do is you would replace negative 5, 11 in the equation, replacing x with negative 5 and y with 11. Okay, so how do we do that? This one's kind of a pain, so I'll kind of do it with you since this one's, really a pain because of the fractions and stuff. You might have to add fractions and that sort of thing. So I'll just work it out with you. Let's try answer choice A. It's either A or B. So I'm going to try answer choice A. If it works, then we know it's correct. If it doesn't work, then we know it's B. So we only have to test one of them in this case. So I'm just going to go ahead and try answer choice A. So I'm going to replace the y with 11. So in this equation, I'm replacing the y with the y coordinate. And I'm going to replace the x with the x coordinate. So negative 4/3. And I'm replacing x with negative 5. So negative 4/3 times negative 5 in this case. And then plus 13/3. Okay. Now, remember, here we're just multiplying this fraction times a whole number. Normally I would say, okay, take the whole number, multiply by the numerator, divide by the denominator, right? Which we could do that here, but in this case, it doesn't divide evenly. So we're actually just gonna multiply by the numerator and then don't worry about dividing because it doesn't divide evenly. So just negative 4 times negative 5 is positive 20. So that's 20 over 3. And then plus 13 over 3. When we're adding or subtracting fractions, we want to make sure our fractions have the same denominator, same bottom number. In this case, they do. And when that's the case, you just go ahead and you add the top numbers, the numerator. Okay, so 20 plus 13 is 33. We still keep that denominator as the same, so that's 3. 33 divided by 3, well, that is 11. Okay, great. So we start off with 11 and we end up with 11. That's great. So that means that's the correct answer. Okay, now if it was a wrong answer, you'd have two different numbers here, like 11 and 12, or negative 11, or something different. But if they match, they are equal, then that's your correct answer in this case. Okay, which equation represents a line that is parallel to this one and passes through negative 10, 30? Well, it's very similar to the last one, except it says parallel instead of perpendicular. So since it's a parallel line, that means we want to keep, I probably should increase the size here. We want to keep the same slope. So we know our correct equation would be y equals 5/2x, and then plus some y-intercept. So our correct equation has to be in this form. So that means it's either C or it's D. Go ahead and plug in this point, replacing x and y in correct, if you do that correctly. You could also look at the previous example, see how we did that. And that gives you a good idea of how to replace the values in. But replace the values in, and the correct answer would give you a true statement. Okay, the correct answer will give you something like 30 equals 30. Whichever one gives you, whichever one of these answer choices give you this, that's your correct. Okay, this one's very similar, except they don't give you the slope right away. So what we need to do is, here we have this equation, and what I want is I want to know what's the slope of this equation. What's the slope of this line? Well, in order to find the slope, what we can do is go ahead and get y by itself. So we're going to start by subtracting 3x on both sides of the equation. That gives us negative 8y equals negative 3x plus 12. I can't combine the negative 3x and 12 here. I cannot combine those. Then divide both sides by negative 8 to get y by itself. Then we'll be in the slope-intercept form. That's good. So that'll give me y equals, here a negative over negative makes positive, so positive 3/8 x. And then this one we can reduce by a factor of 4, so 3/2. Okay, this doesn't really matter, but this certainly does matter here. So our slope in this case is 3/8. So any parallel lines would also need a slope of 3/8. So which of these ones has a slope of 3/8? Only one answer choice has the correct slope. Which equation represents a line that is parallel to the x-axis? So when we draw our x and y axes, the x-axis is the horizontal. So if I want a line that's parallel to that, it would also need to be a horizontal line. So which of these would be a horizontal line? Only one of them will. Which of the equations below represents a line parallel to the y-axis? So this one's kind of similar. When we think about our x and y-axis, the y-axis is vertical. So if I'm looking for a line that's parallel to the y-axis, it would also have to be a vertical line. So which of these would produce a vertical line? Which of the equation below contains the 2 points listed? Negative 8, comma negative 3, as well as negative 8, comma 1. So negative 8, comma negative 3 would be like over here somewhere. And then negative 8, comma 1 would be like here. So a line that contains both of those, well, that would be a vertical line, wouldn't it? Okay, so we're looking for a vertical line, which is always in the form x equals. Figure out which vertical line correctly goes through both of these points. So here we have the line R. You can see here R, which is line FG essentially, is a horizontal line. And we're looking for a line that is parallel to that. So we also want a horizontal line, a horizontal line. So a horizontal line, what is the slope of a horizontal line? Well, the slope of a horizontal line is 0. Okay, so any horizontal line has a slope of 0. All horizontal lines have a slope of 0. Vertical lines, by the way, this will probably come up. These have what we call undefined slope. Okay, this doesn't have to do with this problem, but it'll probably come up later. Which of the equations below represents a line perpendicular to the y-axis? So the first thing I would do, remind myself, okay, this is the y-axis, and I want a line that's perpendicular to that. So if the y-axis is vertical, then any perpendicular line would have to be horizontal. So this purple line here is perpendicular to the y-axis. Okay, in other words, they cross at a right angle. Okay, now it doesn't have to be right here. Any horizontal line is perpendicular to the y-axis. So which of these produces a horizontal line? Which of the equation of the line passes through the point 4, 11 and is perpendicular to this one right here? Okay, well, first of all, since it says it's perpendicular, I'm looking for a line with the opposite reciprocal slope. So our line, our answer, should have a slope of -3/4. Notice it's the opposite sign as this, and it's flipped, reciprocal. And then plus some y-intercept that we don't know yet. But it passes through the point 4, 11. So figure out which of these has a slope of -3/4 and goes through this point. Okay. Which equations, blah, blah, blah. What is the equation of the line that passes through the point -2, 14 and is perpendicular to the following equation? So a perpendicular line, again, opposite reciprocal slope. So our answer should be in the form y equals, now since this is negative in this one, we're going to have a positive slope, and then we want the reciprocal. So positive 5/2 x, and then plus some y-intercept. Okay, plug in the coordinate points. So it's either A, well, I guess it has to be A because it's the only one that has that correct slope. So A will be the only one that's perpendicular to this. Okay. What is the equation of a line that passes through the point 6, 11 and is parallel to the line with the following equation? So a parallel line has the same slope. So the slope here for this line is 2/3. So that means the slope of any parallel line would also be 2/3. So we know our correct answer should say y equals 2/3 x plus some y-intercept, some b. Okay. Now use this coordinate point, replace the x and y. So it's either going to be answer choice B or answer choice C because those two both have the same slope. So both of these are parallel to our equation, but only one of them goes to this point. So replace the x and y with 6 and 11 and figure out which one gives you a true statement. Okay. Again, a true statement would be something like 11 equals 11. What is the equation of a line that passes through the point 4, 14 and is parallel to this equation? So since it's parallel, they would have to have the same slope. So we know our correct answer choice should have the same slope as this one, 4/3. So we know our correct answer will say y equals -4/3 x plus something. And you have to use this coordinate point, plug it in, and figure out which one gives you a true statement. So since we know the slope needs to be -4/3, it's either going to be B or C in this case. And you're going to replace x and y with these x and y from this coordinate point and figure out which of these gives you a true statement. Remember, a true statement in this case will look something like 14 equals 14. Which of the equations below represents a line perpendicular to the x-axis? So if you recall, the x-axis is this one here. So the x-axis is horizontal. If I want a line that's perpendicular to that, that means I would want a vertical line, something like this. Okay. Remember, vertical lines are always in the form x equals and then just a number over here. So figure out which of these fits that description. Which of the equations below represent a line parallel to the x-axis? So this one's similar to the last one, except here when we think about the x-axis, it's horizontal, and we want a line that's parallel to that. So we want another horizontal. These are parallel. This red line is parallel to the x-axis. Now remember, horizontal lines are going to be in the form y equals and then just a constant. Okay. All right. Well, with that, hope that all made sense. Hope you're able to get through all of it. If you have any questions, please comment them below, and I'll try to answer as many as I can. Don't forget to like, comment, subscribe in order to just thank me and also to bless the YouTube algorithm. All right. Well, with that, take care, and I'll see you guys next time.